This is Ship It with Justin Garrison and Autumn Nash, a podcast about everything that happens after Get Push. Ship It is brought to you by Fly.io, the home of changelog.com. Launch your apps close to your users all around the world. Learn how at Fly.io. And welcome to another episode of Ship It. I am your host, Justin Garrison, and as always, Autumn Nash is joining me. How's it going, Autumn?
Hi, how are you?
I'm doing great, and I am so excited for this episode. I want people to hear it like right now, and they are. That's the cool part.
I think this is my favorite episode so far.
Yeah, and this episode is called Shipping in Space. I just wanted to do that really loud.
Be ready for the Justin dad jokes that will come from this.
It's going to be, Andrew gave me some dad jokes too. It wasn't just me, but I know I have some. So.
I like how you're trying to pretend like it wasn't like your idea and you didn't pull Andrew into the dad jokes.
It just, dads kind of orbit each other. And so we have a gravity and, and that's how we start the show. So.
That was such a dad joke.
We want to start the shows with giving y'all links to some neat things that we found, some not news necessarily. This isn't a news show. This is really about the infrastructure and people that build and maintain infrastructure. And today's episode is all about infrastructure and code that's running in space, or as a technicality, I know it's low Earth orbits. Let's just say what happens when your code is falling all of the time. And it's not falling down. It's not crashing yet, but at some point it's going to, and that's pretty exciting. But we will get to that interview in just a few minutes. Right now, we wanted to go into a couple links that we thought y'all might like. And so I'm going to start first, and it's a blog post from SST, which is a full stack deployment tool for deploying applications on top of AWS. And this was a really fascinating article from January 29th, 2024 about moving away from the CDK, from AWS CDK, because their tooling was originally built on top of the CDK. It still is currently, as of writing this blog post, built on the CDK, but they're saying that they're moving away from it and they're actually moving to Pulumi instead of the CDK. And the article has a lot of details about why they're doing that. And I found it very fascinating because a lot of the things that they call out explicitly are things that I've just had feelings about the CDK and CloudFormation in general that I'd never really liked. I've never been a big fan of CloudFormation. I think it has some great use cases, but in general, if I'm going to deploy and manage infrastructure with code, I always would reach for Terraform over the CDK or CloudFormation. And they call out exactly some of those reasons about, CDK is just kind of a hack on top of CloudFormation, and CloudFormation as a service is kind of a black box to them. And there's a lot of things they can't do for ordering, and they kept having to do hack to make sure that their users could deploy things reliably. And so they're just saying that's enough, and they're going over to Pulumi because of these reasons in the blog post. So I found it really fascinating. And if you've ever felt like CloudFormation had some gotchas and some things you maybe didn't like, you probably will agree with this article. Otto, I know you've used a lot of CloudFormation currently and in the past, and you don't have to get into all the details of your feelings about it. But I found it's really cool that they laid it all out and just said, like, we're done. We're not going to try to hack around this anymore.
I always think it's interesting to learn people's whys of why they pick different infrastructure and why they make those choices. My link is about deepfake scammers walking away with $25 million in their first of a kind AI heist, which I think is extra interesting, being that OpenAI released Sora this week. And I think the video of Sora, the video on the fly, and the ability that Sora has made a lot of people super concerned about deepfakes. And I think we've all been sort of concerned, but now the fact that it is readily available and easily available is going to make people even more concerned. So this was a highly convincing fake video and audio that they used to fabricate content to get $25 million from a bank in Hong Kong. And it's kind of amazing because it took it was a multi-person video in a multi-person video conference where it was fabricated images and individuals. So it's not like it was a video that somebody just gave and they just assumed it to. They like actually used this in a video conference and posed as like bank officials to get them to release this information. So with elections coming up, with banks, with so many different aspects of how this could hurt the community. I mean, there were Taylor Swift pictures of her doing like not appropriate things or whatever you would call it, and they made these fake pictures. And even though like places like OpenAI and Sora and these different AI companies are saying we're going to have all these guardrails, how long until people learn to pick just what they want without those guardrails and start using it maliciously? So it's interesting where this could go and what effects it could have. I think it'll also make some really cool things, which is exciting, but
Tools are tools, and
exactly.
they can be used for both. And I this article specifically, I heard another breakdown of like what at least they thought happened or what came out from happening, because I know at least the original article, like they didn't say what bank it was, or why, but basically someone had access to transfer funds and they sent them emails and invites and made fake accounts on that video call for people that would be in charge of telling them, hey, you need to transfer this money. So like the CTO or legal advisors or whoever that worked at the bank, calling the person that had the access to say, okay, transfer these funds. And then multiple people on a fake call, basically all AI generated with audio and saying like, hey, I need you to transfer this. It's urgent, yada, yada. And it's like, if I had 3 people at my company tell me I need to do something.
That's a scary thing because they didn't even need real accounts. You know what I mean? Because somebody, they could have found one person. And if you have somebody high enough level, like they would have had a way to do a wire transfer because they're thinking that their boss or a CTO or these high level officials are giving them these direct orders, you know, and there's more than one person. So it's like, even if they didn't have those accounts, and it's like, how many other ways could this start to affect? Like they fool grandmas with IRS scams on the telephone, and then they're going to have video. Like, how do we now educate people about this? You know, like how do we educate people around misinformation? Like, think about just what happened with like memes on Facebook during our last election. Like, this is going to be like, I don't know if we're ready at a level of how to educate our, you know, community on a global scale to fight the amount of misinformation that this is going to be able to turn out, and it's going to be able to turn it out so quickly that like, how do we bring people's awareness to this? Like, if you don't work in tech, do you even know that like videos like this exist? You know, like how do we then differentiate between the two?
Yeah, and even all of the guardrails and laws that we might have in this country, that doesn't apply when someone's calling from another country or
Exactly. And not just that, but what happens when countries weaponize this? You know what I mean? Like, it would be very easy for two countries to weaponize this against each other. All you need is one fake video of a public, you know, a government official from another country where to start a war, you know? So that in itself is very scary and dangerous.
yeah, for sure. At some point, there's real people and real money on the line.
Exactly. It's not just servers, you know?
Yeah. Fascinating, and I'm interested to see, just keep following these sort of things. I'm 100% positive this is not the last time we're going to hear of AI being involved in either scamming or some sort of heist or money being stolen. And especially at, this $25 million is a lot. I don't think that's going to be the maximum. Like this is going to keep going until we figure out how to identify that.
It's amazing. Every time I see a new thing, I'm like, this is going to be so cool. You could use it for this and you can use it for that. Like, can you imagine as a little kid being able to think up a story and then telling a computer, hey, go act this out with my favorite cartoon characters? Like, that is wild. But at the same time, like, please don't cause anyone nuclear war. Like, you know.
The good and the bad, right? Because I hear so much around like AI for education and for helping like a kid who needs this very specific, either special needs or special tutoring to say like, hey, I need someone to explain this to me the way I understand it. And that's super powerful because the teacher can't do that when they have a class of 20 or 30 or 40 kids. But a chatbot, sure, like that's actually, they can give them the diagrams and the things that would help individuals learn things better. But then, yeah, you can turn that right around and say like, oh, like this is unlimited power for whatever I want to do and create.
Just like at a point, like I love Beautiful Soup as a Python library and I love Twitter, but people were doing horrible things with scraping the internet and then having chatbots regurgitated on Twitter and use it to be hateful. which you could also post a bunch of really cool things you're interested in. Like I made one about coffee and like video games and and then somebody used it to harass Meghan Markle. Like so like it's just insane. Like I guess it's whatever floats your boat.
All right, well, let's jump right into the interview because I'm sure everyone wants to hear from Andrew about what it's like to run software on satellites in space. And we're going to jump right into that and we'll see you afterwards.
What's up, friends? This episode is brought to you by our friends at SPAAAACCEEE. SPAAAACCEEE is helping teams take NAS to the next level via a global, multi-cloud, multi-geo, and extensible service fully managed by SPAAAACCEEE. They take care of all the infrastructure, management, monitoring, and maintenance for you so you can focus on building exceptional distributed applications. And I'm here with VP of Product and Engineering, Byron Ruth. So Byron, in the NATS versus Kafka conversation, I hear a couple different things. One, I hear out there, I hate Kafka with a passion. That's quoted, by the way, on Hacker News. I hear Kafka is dead, long live Kafka. And then I hear Kafka is the default, but I hate it. So what's the deal with NATS versus Kafka?
Yeah, so Kafka is an interesting one. I've personally followed Kafka for quite some time, ever since the LinkedIn days. And I think what they've done in terms of transitioning the landscape to event streaming has been wonderful. I think they definitely were the sort of first to market for persistent data streaming. However, over time, as people have adopted it, they were the first to market. They provided a solution, but you don't know what you don't know in terms of you need this solution, you need this capability, but inevitably there's also all this operational pain and overhead that people have come to associate with Kafka deployments. Based on our experience and what users and customers have come to us with, they would say we are spending a ton of money on spend on a team to maintain our Kafka clusters or, managed services or something like that. The paradigm of how they model topics and how you partition topics and how you scale them is not really in line with what they fundamentally want to do. And that's where NATS can provide, as we refer to it, subject-based addressing, which has a much more granular way of addressing messages, sending messages, subscribing to messages and things like that, which is very different from what Kafka does. And the second that we introduced persistence with our Jetstream subsystem, as we refer to it, a handful of years ago, we literally had a flood of people saying, can I replace my Kafka deployments with this NATS Jetstream alternative? And we've been getting constant inbounds, constant customers asking, hey, can you enlighten us with what NATS can do? And oh, by the way, here's all these other dependencies like Redis and other things, and some of our services-based things that we could potentially migrate and evolve over time by adopting NATS as a technology, as a core technology to people's systems and platforms. So this has been largely organic. We never, from day one, with our persistence layer Jetstream, the intention was never to say, we're going to go after Kafka. But because of how we layered the persistence on top of this really nice pub sub core NATS foundation, and then we promoted it and we say, hey, now we have the same semantics, same paradigm with these new primitives that introduce persistence in terms of streams and consumers. The floodgate just opened and everyone was frankly coming to us and wanting to simplify their architecture, reduce costs, operational costs, get all of these other advantages that NATS has to offer that Kafka does not whatsoever, or any of the other similar offerings out there. And you get all these other advantages that NATS has to offer.
So there's someone out there listening to this right now. They're the Kafka cluster admin, the person in charge of this cluster going down or not. They manage the team, they feel the pain, all the things. Give a prescription. What should they do?
What we always recommend is that you can go to the NATS website, download the server, look at the client and model a stream. There's some guides on doing that. We also have SPAAAACCEEE provided basically a packet of resources to inform people, because we get, again, so many inbound requests about how do you compare NATS and Kafka? And we're like, let's actually just put a thing together that can inform people how to compare and contrast them. So we have a link on the website that we can share, and you can basically go get those set of resources. This includes a very lengthy white paper from an outside consultant that did performance benchmarks and stuff like that, and discuss basically the different trade-offs that are made. And they also do a total cost of ownership assessment between people who are organizations running Kafka versus running NATS for comparable workloads.
Well, there you go. You have a prescription. Check for a link in the show notes to those resources. Yesterday's tech is not cutting it. NATS, powered by the global multi-cloud, multi-geo, and extensible service that is fully managed by Synadia. It's the way of the future. Learn more at synadia.com/changelog. That's SYNADIA.com/changelog.
All right, thank you so much, Andrew Guenther, for being on the show today. And today we're talking all about shipping in space. And so welcome to the show. And my first question is, when you have some code that's running in space on a rocket ship, and if it's a class that's maybe is undeclared, is that an unidentified flying object?
Ooh.
Sorry.
Oh, that's a boo. That's a boo for me, dog.
We don't even have all the context here. What do you do in
Just
space? I have so
out
many
the gate.
questions. I know.
I literally was up last night and I thought of that. I woke up and I was like, that's the joke. And I'm like, oh, I'm such a dad. Anyway.
He didn't wake up with a line of code. He woke up with a dad joke about space. I love it.
I get that, though. We all go through that phase.
He's like, I feel you. It's okay.
So anyway, bad jokes aside, Andrew, tell us about yourself and what you were doing at Orbital Sidekick.
Yeah, for sure. So I'm Andrew Guenther. I work for a company called Orbital Sidekick. So Orbital Sidekick operates a constellation of hyperspectral imaging satellites. And basically what that means is they have these cameras that can see way outside of the visible spectrum of light, so they can effectively perform spectroscopy from space. So gases that would normally be invisible to the naked eye are things that their cameras can see. And so their primary market right now is customers like oil and gas who are like, hey, let us know if our pipelines are leaking. So OSK basically processes their own imagery, determines where leak sites are, and forwards those on to customers. They have customers in government who buy raw imagery, looking to expand out into other industries. As you can imagine, with these kinds of cameras, there's all kinds of cool stuff you can do. You can monitor plant health. You can help with mining prospecting. So very, very cool technology, still in the early stages. 3 satellites in orbit right now, 2 more launching in March-ish. Don't have exact dates yet. But a little bit more about me. So I am principal software engineer at Orbital Sidekick. Prior to that, I worked at AWS for 7 years. So basically, I left AWS, joined OSK as lucky employee number 13, and got to build a lot of their ground segment systems from the ground up. As time went on, I got to be a little bit more involved and help out on payload side as well. So kind of the V1 of all of OSK systems, I got to sort of touch, and then moved into this role of wherever the fires are, I moved around to put those out.
And hopefully not physical fires. I mean, these are spaceships and rockets.
No, thankfully, no physical fires.
Okay, we just became best friends. I'm so excited right now. I'm trying to parse the amount of questions in my brain because that's how excited I am. So you're building the software that processes the images, but also is it are you building the software that is on the satellites? So
it's interesting. OSK is a company of about 30 people.
Do you need 31? Because
applications are open.
Okay, cool.
It's interesting. So being that small, we have to work with a lot of vendors to sort of pull things together, but the payload design and a lot of the core software for image processing, we write ourselves.
What language do you write image processing in?
So the image processing on ground is all in Python, and the firmware for the sat is C++, as well with some Python mixed in. So one of the big value props for OSK is that we try and perform some of the imagery analysis on board the satellite before it even comes to the ground.
What?
Yeah, because you have this incredibly wide spectrum imagery, the data is huge. I mean, we're talking these satellites can bring down 1.5 terabytes of imagery per day per satellite. And so part of the idea is the more processing we can do on board to understand what imagery might be a priority versus not a priority really helps us get that information to our customers faster. So there's also this aspect of the analysis we write on ground should be analysis that we can hopefully perform on board as well.
That is so cool.
We ship NVIDIA hardware up to space. Like we are running a like NVIDIA dev board in low Earth orbit.
I'm just thinking of NVIDIA drivers now, and I'm like, oh, like that's the worst. Like trying like on a Linux embedded system. Well, how
a Linux embedded system that you never get to touch again, right? It goes up and you're locked in.
If something goes wrong, like how do you fix it when it's like in orbit?
Yeah, I mean, this really gets into redundant systems, right? So a lot of the components on board, there's at least two, our own components. So our own dev board, I forget if there's one or two of those, but there's kind of like a main control computer that exists separate from ours that kind of handles a lot of the boring stuff, like pointing the satellite and doing the actual hard work of transmitting data back down to the ground. And then our dev board basically handles all of that image processing, sending commands to the camera. So effectively, we have capabilities to like fail over from one component to the other. Or if we're rolling out an upgrade, we roll it out to XCOM 2 and then we primary swap to XCOM 1. And so it's almost like an A/B test in space, right? Or kind of like a canary. So you upload it to one of the XCOMs, you swap over to that, make sure everything still works. Great. Roll it up to the second XCOM. Everything still works. Great.
I feel like you have to write really good code and you have to really think about your hardware because you never get to touch it again, And you could miss a picture.
100%. And this is one of the crazy things. I mean, even in a startup, like an aerospace startup, the dev cycle on hardware is super long. So, a lot of the hardware was designed and locked in and figured out before a lot of people got hired. Like the hardware was decided before I even got hired.
Which is crazy. You said you were number 13, right? So
yeah.
That's like really early.
Yeah. So there's a lot of, by the time these things go up, like, you've got 3 new generations of NVIDIA dev boards that have come out. You're running like Ubuntu 18.04 in space for the next, half decade.
Yeah, long-term support has a different meaning when it's flying around the world.
Yeah, it's like LLLTS, long-term support.
Which it's funny because people like kind of make jokes about like NASA and different places and how they use like in the government and how they use outdated technologies. But when you really think about it in context, there's a reason why they're still using that very reliable technology because, hey, you can't go change it every.
Yeah, because you got to test the hell out of it before it goes up. And it's so interesting to kind of see this boon of aerospace startups. Like before I came to OSK, like I didn't work in aerospace. Like I said, I was at AWS and I also had the draw of like, I want to work on space stuff. Like that sounds awesome. And seeing this smashing of startup culture and aerospace, like you have this culture that wants to move incredibly fast and this culture that's traditionally very slow, trying to like figure out like where does this all meet in the middle? How do we speed this process up, become more agile? And that was to me like one of the most interesting things to observe.
First of all, that's really cool when I think about like 30 people, 3 satellites, right? Like 10 people per satellite in space. You're going to have a couple more. And like, that's like the opposite scaling of what I think of for like running systems where it's like one sysadmin can do 100 machines. It's like, but like a spaceship, like it's literally a satellite takes so much time and process. What does that actually look like for you of, we're going to make another, satellites. It's going to go out next year. Like what is that lead time for like what you're writing today? What decisions you're making around libraries and code? And then like, how do you get feedback for that? How do you make sure that like that thing that you think is going to be accurate next year gives you any kind of feedback loop?
Oh man, there's so many great questions to unpack here. So I'll try and go at it one at a time. So one of the saving graces to some degree is that as we launch more satellites, they're all based on the same hardware designs. Like very minor revisions between them, right? Like you have a satellite that works, like don't mess with it. Continue to launch more of the same. So, but then also on the flip side, right? When the first one goes up and we realize like, we really should have done some things different. Like as we learn, that iteration cycle is even slower. So there's a lot of things that we have to kind of deal with on ground, and we're making notes for what the next gen hardware is going to look like, additional concerns. And when you talk about, what kind of packages are we going to use, that's a huge concern of ours, right? It's running 1804 in space. We're trying to do machine learning and data analysis, a lot of those libraries move very fast. They're very quick to drop support for older operating systems. So, we have to make the call as a small team. Are we going to compile these ourselves? Like, are we going to build our own versions of these dependencies to maintain them? So we're very cognizant, especially on the onboard data processing side, of what libraries we pull in. I mean, more so than anywhere I've ever been. Because not only is maintenance a concern, size is a huge concern. Pushing software updates to space is hard, right? It takes a while. You're gonna test the hell out of it, and you want to make sure that it works. And so I like to pick on Node.js because you have like the npm package system, right, where just everything sprawls out to infinity. You install.
They're ridiculous. 65 warnings. Like, you're just like, what?
Yeah, you install one thing and suddenly now you've got like 100 gigabytes of dependencies. And even in Python, right, like we have to be really careful of that. Like, what does our dependency sprawl look like? And we've made conscious decisions to say, that sprawls out a little too much. Like, we're not going to use it. And something we really try to hold to our own frustration sometimes is parity between space processing and ground processing. So there's a library where it's like, all right, well, we don't want to ship it to space. Are we going to use it on the ground? I don't know. Maybe now we've kind of separated these paths and it makes it harder for us to verify results between the two. So those are the kinds of things that we have to think about. It's interesting that to some degree, even space decisions can slow down ground decisions to some degree.
It's really interesting because you're kind of developing in like the paradox of like all developer like angst, I guess, or problems. Like, okay, so you want to build something with low dependencies, something that's not going to be vulnerable, something that's going to last for a long time. But then how do you pick that? You have no control over software life cycles of other people.
And you have to know like 3 years in advance.
That's what I'm saying. And like, how do you account for vulnerabilities? Like, you're going to have to patch things eventually. So like, how do you patch in space? There's going to be a CVE for something.
Yeah, I don't want to fall into the trap of it's in space, so it's safe. Right?
The attack surface is a little different than what a typical server might have.
Yeah, it's a very different attack surface, but I will kind of pull that card a little bit, at least as far as the Python side of things goes. That system is very isolated. Like, we're not running a web server up in space, right? But I will, to the point of security and CVEs happening in space, Space Force is actually making a huge push. They were at DEF CON last year. I got to go and watch they held the hackathon, which was very cool. The Space Force launched a satellite for a hackathon.
I still can't believe Space Force is like real. Like, every time someone says it, it makes me happy. Like,
it's pretty amazing.
Like, that sounds just so cool. Like, I work at Space Force. Like, no big deal. Like, right?
Central Space Command,
Yeah. Like Buzz Lightyear in real life. Like, it's awesome.
Yeah, so it's important to not fall into the trap of like, we're in space, so we're safe, right? And especially in that startup culture of like wanting to move really fast and compete with these bigger guys, that's something that we're very cognizant of and trying to find those right balances.
How do you make decisions and like what kind of tenets do you have to like, I guess, develop? Because you both want to develop quickly because everybody wants to innovate and develop quickly, and that's how you get an edge on your market. But also, like, how do you make that last for so long? And then how do you do it with like, I was writing an automation script and we were trying to get rid of like dependencies. So it's like, okay, I won't use Panda, I'll use like Python, like, like the things that come with Python, right? So like trying to like develop on that level on just a small automation script made it so much more complicated. So I can only imagine like image processing.
It's a big push-pull, because you definitely want to try and keep your space systems as simple as possible. And we're very much breaking that mold by saying like, we're going to do imagery analysis on board of a satellite. And so it's definitely something that we're cognizant of. And we have this nicety that we can test a lot of things out in the ground segment. We can use those libraries on ground initially before we make the call of, this is something that we want to run in space, so let's retrofit. We can use all those nice libraries, have 100 gigabytes of dependencies to prove out those analyses on ground. And then when we want to say, okay, this is high value, we want to run it on board, we can take that step to say, all right, let's strip this back. Let's make this bare bones. How do we leverage what's already on board to now ship this thing up to space?
That working backwards.
Yeah. Yep.
Fundamentally, a customer comes to you and says, I need you to look at something on the ground. You're not running customer code in space, right? They're giving you a job to say like coordinates, please send me this data, right?
Yep, exactly.
You're going to go point the iPhone 25 at this ground spots and like get this image back. It's going to transmit down just like a terabyte a day out of this. Like you're just taking pictures constantly. And then you process that a little bit more and then send them either raw data or whatever it is that they're looking for, right? Like that's the general pipeline here.
Yep, you got it.
What was the benefit there of not making the satellite a dumb client and putting intelligence in the satellite and on the ground? Because it feels like you could put that either place, and you chose the hardest decision to put it in both places.
Yes.
like there has to be value that you're getting out of doing that process before. I mean, if you're just sending a terabyte, like, I don't know, was that just a big antenna with a satellite dish up there, just like beaming down death rays of pictures?
So that antenna that actually performs that 1 terabyte a day downlink, we get a pass on that antenna every 90 minutes. So if you have a really critical, high priority workload and your objective is to deliver some insight to a customer as quickly as possible, you might not want to wait that 90 minutes. And even after that 90 minutes is up, it has to get to the ground. It has to be processed then on the ground before it finally gets delivered. So the idea being, if we can prioritize, because we're also not able to get down all the data we may have on board every pass. So it's kind of twofold, right? If you can say on board, hey, I have very high confidence that there is a methane leak at this position, that is a much smaller piece of data, and there are other antennas that we can use to transmit that data more instantaneously. And then secondly, maybe you have a little bit less confidence, but something is suspect, you can say, all right, on our next pass, this data skips the line. We're going to downlink that first. And we're going to make sure that gets analyzed as part of this pass so we can get that information out as quickly as possible to customers. But it is definitely the hardest of all the options. You're right.
So kind of like how they're using machine learning to look through ultrasounds, but you're using it to like basically prioritize data from satellites to bring that down first.
Yep.
It's really cool.
How do you debug that? Like, is that only like you have a dev box on your desk and you're saying like, oh, I think this is what's happening, right? Like at some point when you debug something, you just have to kind of poke at it. But I can't imagine like that latency, you have a 90-minute window. I don't know how long that window lasts, but you're like, oh, I got a shell for 89 seconds. Like I got to jump on the box and like poke at something.
Yeah. You can SSH into space for like a hot 5 minutes and take a look around. So, there has to be some planning ahead of time. Like if you want to run some set of debug scripts, you're going to want to know ahead of time and just run that in an automated way rather than just like maybe having a terminal open, and which we've done. we've done, especially after the sats first went up and we were trying to better understand the characteristics of the first one and just get a sense of what was happening live. There was a lot of like, all right, time to SSH.
I can only imagine the like constant Tmux session. That's like, you're like, oh, it's coming back up around. Let me connect to it again. Hold on. That's just amazing.
We don't have space for Tmux, man. It's a fresh shell every time.
Oh, and then your SSH hangs and you're like, dang.
Yeah. That's
Man, that is exactly what I would hope to be.
Yeah, it's the dream.
There's so many challenges in this. What would you say is like one of the things that stood out to you as like something you didn't expect? Because I mean, you're going into this knowing this is going to be a hard thing to do. There's a lot of variables and things at play. What was something that surprised you about shipping software into orbit that you're like, wow, like I didn't see that one coming?
Yeah, I think, and maybe I was uniquely naive in that, I think everybody has that vision built up of like how NASA does things, right? And you imagine clean rooms and this perfection and just everything is immaculately tested. And I'd say that there's not problems, but it's you have that vision of that much slower pace. And I think what was surprising to me is the speed at which we can move and the amount of chaos that introduces, and that it's okay. Like there was a lot of thought put in up front, right, around those failure modes and understanding and basically protecting ourselves, our future selves, so that when things do get chaotic and things do break, we have the levers that we can pull. So it's not clean rooms. There are clean rooms, but you take a drill, do a test, and it's like, oh man, we need to like route this connection somewhere else. And somebody just like takes a drill to a frame and they're like, all right, let's send it to space. That just kind of like shatters your view, right, of how kind of the way NASA does things. And I think that kind of goes to what I was saying earlier about this meeting in the middle of this startup culture wanting to move fast and that entrenched aerospace culture of moving very, very slow. right? If we can launch a satellite for, say, like $5 million, why are we going to run a $5 million on-ground test for that satellite, or a $10 million on-ground test for that satellite? Like, we can launch 3 for that price. And if one of them works, we're great. So I think that's kind of where that push and pull really comes into play. And I think that was really surprising to me, was just how much leniency there was towards moving fast. Like, I didn't expect it to be able to move as fast as we've been able to move.
I wonder what the culture was like in the 60s, right? When it's like, we are landing on the moon. Because that, like, they had to move fast, right? Like, my grandfather actually worked on the Apollo missions, which is just like, his pictures were absolutely amazing. And I never got to hear stories from him of like what the culture was like. But I can only imagine that, like, at some point, you're just like, no, this has to happen this decade, right? Like,
Yep.
someone said we're going to the moon. And the fact that, like, so many people and so much funding and money was in place to do that. And now on the opposite side, where it's like, no one told you to do this. Like, no one told you this is the thing we have to do. And so the initiatives were very different of like, hey, we see where we can add value to people that maybe had to drive their truck for 2 days to go see this pipeline or something like that. You're like, hey, I got you in an hour and a half, and you're going to get your images and they're going to be processed, and we'll see all the stuff that maybe you couldn't see before. And that's just pretty amazing to be able to add that value that quickly.
Yeah, it's nuts. I mean, this is something that even 10 years ago wasn't possible, right? Like, launches have become way cheaper. You know, $5 million is a lot, but in the grand scheme of like Silicon Valley VC money, that's not a lot. And it's become super accessible for startups to launch payloads into space. It's high CapEx still, for sure, but it's possible when it really just wasn't before. And I think, to your point, we're seeing that transformation in a lot of industries. You know, for oil and gas, the state of the art was like, once a quarter, they would pay some kid trying to get their pilot's license to just like fly and look out the window of a Cessna and like, do you see any leaks? Nope. Right? That's what we're going up against. That's what we're replacing. And it just feels like such a huge quantum leap forward for that industry. And we see that with customers, right? They're super excited. I mean, because it's space and it's cool, but also just it is such a faster feedback loop than anything that they've worked with before.
That's wild that you can do something in space that much quicker. Also, I think it's really going to add, I don't even know if I'd say add value, but it really sets you apart if you can move fast and cheaper because of the market that we're in right now and less VC funding and higher interest rates. That's awesome that you've been able to add so much value, but also like iterate faster and at a, I guess, smaller cost, you know? Even though $5 million isn't anything to like.
still high CapEx, but lower than it used to be CapEx.
Yeah. I mean, like back in the day, the only people that launched anything into space was NASA, you know? So the fact that it is even an industry that multiple people, like, or multiple companies can do, you know, is kind of just wild in itself.
So my dad also worked in aerospace. And when I told him that I was coming to this company, he was like, you mean you're just a bunch of guys and you put some satellites in space? It's like, yeah, they just let us. For real. You just apply for your FCC license and like let NOAA know. And they're like, yeah, go for it.
Which is like wild. There's like no space license or something. Like, you know.
It's interesting because there kind of is. So it's governed by the FCC because they control the radio waves. I got into like a whole conversation with somebody on Hacker News a while ago about this because I just find this fascinating, like how the US finds really unique ways to have regulatory vectors over stuff like space, right? And the FCC is like the main body for that because they govern the airwaves. So it's basically, if you want to transmit within the US, you need an FCC license. And if you're launching a satellite, you probably are going to want to transmit in the US. So you need a license from the FCC to launch a satellite.
It's like wild because I think through crypto and NFCs, we've seen what happens when we don't have regulations. But then sometimes you're just like, where do these things come from? Like the FCC is not what I was guessed of, like your space license. You know what I mean? Like,
yep.
So that's like, who would have even thought? But also at the same time, like, you know, when you're a kid and you think of space, you think of doing so much more to be able to launch something into space. And that's just wild that it's just like, check what the dudes do airwaves and then you can put whatever you want up there.
Yeah, and even better, the FCC issued their first fine for space junk a couple months ago.
Oh, that's cool.
The Federal Communications Commission, the champions of litter in space.
But it's also interesting though, because so many things get launched, right? And like even if it doesn't go wrong, there's just so much that doesn't go with your like rocket or whatever. Like they're made to have parts that break off. So like I don't like did people even think about like what we're gonna do with all that at some point and how we're gonna collect all that?
It was just like let it all burn up. A lot of these our satellites don't have propulsion, so after X number of years, the orbit decays and they burn up, and that's game. And
do they really just burn up completely?
Mostly so.
What's the lifespan? We're talking like servers are like 7 years, right? Like I can buy a server, put it in a rack, and I hold it for 7 years. You launch a spaceship, and how, or not a space, I don't know a technical term. Now it's obviously a satellite because there's no propulsion or anything. What is the lifespan of those first 3 satellites that you launched?
So there's a difference between like orbit decay and mission life, because the components on board in theory will go out long before the actual orbit will decay. So I believe the satellites are slated to be a 5-year mission from the onboard component perspective. But this is like, that's still kind of like NASA grade ratings, right? Ideally, you get way longer than 5 years. And then I think the orbital decay is like 15 years, closer to 10, 15 years it'll take before.
But do they completely like dissolve or like, because you know how like the rovers, like one will be like, it'll live way longer than they're supposed to. And then one gets like too much dust. And then like the like solar plates can't keep like powering it. Also, I cried. Like I was so like in my feelings about the rover. Like I was like,
just out there all alone. Love your
pictures. I know, like it was so lonely and I was so sad. Like I was like really into I was so sad. My kids are like, what's wrong? And I was like, the rover.
You build up feelings around these things. It's funny because each of our satellites we name after a sidekick.
Oh.
So our like the official designations are like Ghost 1, Ghost 2, Ghost 3, but we call them Robin, Goose, and Chewie.
Oh my god, what if Goose dies? Like I would like
yeah, like Goose is ill-fated. That poor.
Are you trying to make us cry, Andrew? Like if you had to name it Goose, like
That's definitely not the objective. This is just a plug for that. We have a Slack bot that announces like telemetry and new imagery, and it uses a picture of the appropriate sidekick and like speaks as if like Goose checking in, got new imagery.
You have a Slack bot with pictures and it Andrew, hire me. Like like wait, like you get paid to do this? Like I am just like I like literally stalk all of like James like Weber and like all the different satellites and like post them like a crazy person. Like just I'm like we're best friends now. It's happening.
I mean, talk about like pets versus cattle, right? Like this is the epitome of like you have a 15-year decay, but also like $5 million for a 5-year mission, right? Like $1 million a year per satellite. And you are going to get more than $1 million of value or revenue from that. Like that's an interesting, like just calculation to be able to say like, hey, this is how much it costs us to upfront. And you've upfronted the money for the FCC license and all the other things. So like we need to push this thing into orbit is just really amazing to really think about.
Well, and you want to talk about crazy scale, like look at Starlink. They have some rudimentary propulsion, but they're even, I think, on a less than 15-year mission cycle, and they're launching thousands of those. Right. It's just crazy.
Like Starlink, do you have satellite to satellite communication to like help with that 90-minute delay? And will 5 satellites like reduce that for you significantly?
Yeah. So we have a radio for satellite to satellite communication. They're not enabled yet, but feasibly, yes. The more satellites you have, like the better network you have, and you can kind of communicate in between. There's also proposals kind of going through for a larger network. So like we could, over encrypted communication, like talk to satellites that aren't ours and kind of like everybody working together to get data down faster.
Would that be like the outro net? I don't know what that you call that instead of the internet. Like this is.
You guys have to name it something cool. After Space Force, you can't just, and like you named a satellite Goose, like the bar is high. Like.
Yeah. Inter-satellite communication networks are definitely something that's up and coming and trying to get off the ground. It's a bad joke.
I got the pun. I was late on that, but thank you.
Are you about to dad joke us? Like,
who's the jerks in space? Like, is Starlink, like, is that like, you're like, they just litter everywhere and we can't see around them? Is there some other, like, these people don't have this, like, another country that's like, well, they're not working with the FCC, so like they just threw, like, I don't, like, if you can't answer it, that's fine, but like, I'm curious now, like, is there like space beef between like satellite vendors now?
You're gonna get Andrew in trouble.
I mean, there's only like low Earth orbit is smaller than you think, and I would say, like, without naming names, the jerks are the people who are just launching tons and tons, which is pretty much anybody who's looking to offer satellite-based internet, right? Satellite-based internet takes an absurd number of satellites. It's easy to pick on Starlink because they were the first, but they're not the only, and that's going to continue to crowd low Earth orbit, which again is the most accessible orbit for people like us. And, you know, these things, like, you can't understand an orbit out with accuracy multiple years. Like, these things, like, they're going to collide at some point. Like, there will be collisions, and there have been close calls. And what's crazy is, like, we got a call, like, we actually got a call for one of our sats, and they were like, hey, you're going to pass really close to a Starlink satellite. Just heads up.
How close is really close? Like, I think a space is like you're hundreds of miles away, but no, this is really close. Is probably
close enough that somebody called, right? Like,
Can you change like the course of direction if you're going to get too close, or are you just kind of like, it's just out of luck and you're going to hit each other?
us, no. Starlink has some rudimentary propulsion, so they can do some stuff. I mean, even the space station had to move to dodge. I think there was like a Chinese satellite where they were like, hey, there's a satellite that we have, and you need to move the space station so that our satellite doesn't hit it.
Just move a whole space station. No big deal.
Yeah, if you could just like shift altitude control a little bit and like, yeah, just real fast.
But what's the heads up for that? Is that like you have 10 orbits and then you're done? Or is this like, hey, like 90 minutes? Like,
How long does it take to move a space station? Like, this is wild. Like,
I don't know the answer on the space station, but for ours, it was just this like tense hour and a half, right? Because we get that telemetry down, and then it's like, all right, this is the orbit. And so we're sitting there waiting, and
hope Starlink moves.
yeah, and then like 90 minutes later, we get that ping, and we're like, oh, thank God.
I could just imagine you're like wiggling the camera, like trying to focus back and forth to like get out of the way. Like, maybe we can move something.
That goes back to like, it is a lower cap of like $5 million, but still that would really suck if somebody just runs into your $5 million space like satellite.
Yeah, just game over, right?
Yeah, the work that you like, I mean, I can't imagine how much work it takes to get them into space, and then like the cost, and then someone just runs into it really quick. My bad. Like,
especially for us when it's like one of three, right? That's a 33% reduction in our total capacity, which is like super meaningful to the business. Like, each of these satellites matters for us. I do have, in terms of the bullies in space, I do have one other very funny anecdote, because I have beef with the Vatican.
Hold on.
wow, that is a powerful person to beef with. Like, I'm here for it.
The Vatican has a space program. Fun fact.
What? The Vatican? Okay.
The Vatican has a space program. You can read all about it. It's called Spy Satellites, funny enough, but it's SPEI. It's Italian. Cut them some slack, but the humor of it is not lost on me. So they actually launched on the same rocket as one of ours. And so one of the processes you have to go through when you launch a satellite is you basically call up NORAD and you're like, hey, this unidentified object you're tracking in space, that's ours. They know like who's who, what's what. Well, they don't know who's who. You've got to tell them.
Do they give you Santa's number when you call, though? Yeah.
That's the first thing. It's press 1 for Santa, press 2 to claim your satellite is basically the call tree order.
But every time they're like, the call options have changed.
Yeah. The call options have changed. Press 1 for Santa, 2 for satellites. And so when we launched, the Vatican called NORAD and claimed our satellite incorrectly.
No, you got scalped by now with the Vatican.
We got scalped by the Pope, man. We got scalped by the Pope. It's the greatest meme of all time internally. Of just like,
dude, when you're like a great grandpa, you should be like, this one time I worked in space, and then the Pope tried to steal my satellite. Like, do you have baller like work stories? Like,
man, coming from the outside, like the conversation I had with our main space systems guy of like, how do we get our satellite back from the Vatican? And he's like, it's just a naming thing. Like, it's not a big deal. I was like, no, tell me it's a big deal. I want to believe this is a huge deal.
You just wanted to start a fight with the Pope, didn't you? Like, you were like, send me to Italy. Like, we will like have this out. Like,
100%. Yeah. Like we got beef.
So your satellite is forever. NORAD always thinks your satellite is now.
No, so we managed to correct this clerical error, and we've properly identified. Yeah,
Clerical. That was good. That was a pun.
I'm far enough into daddom that they just roll out, and I don't even think.
I was
about
gonna
it
say,
anymore.
are you a dad, Andrew? Because
I
like
am.
you have to, dude. Can we talk? Like I went to go like talk at my kid's school, and they're like, "Oh, cool, you're an engineer." But like Andrew wins every time. Like my kids are like, "Oh, you build Java," and the only thing I can say is that Java builds Minecraft. That's the only cool thing. Like my kids don't care if I build Java, but when you get to say like I work in space, like you win coolest career day dad ever every time.
I do appreciate that I have like a job that my kid kind of gets. I can be like satellites, and she's like, yes,
So cool.
space,
Like rocket,
understood.
space. That's a whole childhood, like, you know how like they get into dinosaurs, they get into like space is like a whole thing. That's like a chapter, like in childhood.
But then she brings home pink eye, and I'm like, come on, man, we gotta.
Dude, my kids brought home hand, foot, and mouth like the other day. Oh, why?
I'm like, I am
Like,
currently on drops for pink eye, and it's just the worst.
oh my god, why do they always get us sick? Like they're just like, oh, we love you so much, and we're so cute.
Please don't include this in the outro. I just imagine the episode's gonna end with this like conversation on pink eye, and like,
dude. Have you seen the meme where the like alien is like breathing in the like lady's face and it says when your kid's sick and they're like, I love you, and you're like, ah.
Yeah.
Okay, wait, before we leave, what's the craziest thing you've had to fix in space?
Oh, this is a great one. So the craziest thing, so I mentioned these that we have multiple radios on board, right? We have this like super high bandwidth one, and it's one way, and that's where that 1.5 terabytes down comes from. We have this kind of like satellite to satellite. We have a much slower one that's more for like command and control sort of deal.
SSH.
Yeah, that's where all the SSH magic happens. And effectively, the way this is all supposed to work is imagine like TCP, where your packets come down over this fast one, and then we send the ACKs back up the slower connection. And we could not connect over that slower connection when we first launched. And so you basically like ran into flow control where we would try and like downlink imagery, and it would give up after like a few megabytes because it's like, oh, I'm not getting any ACKs. And so I got pulled into that, and we basically we pushed this like really small patch up to the spacecraft to basically like ignore ACKs, like pretend ACKs do not exist, and just blast this data down. Because we're a startup, and we're trying to like, we've launched our satellites, and investors and customers are waiting for like those first pictures, and we're trying to like as quickly as possible, as quickly as possible get these things down. So we ended up pushing up this patch to basically ignore the ACKs. And we ditched the file transfer client entirely on the ground, and we just started running packet captures. Like we just ran TCP dump on this thing, and just started like built this catalog of like terabytes of TCP dumps. And then we wrote a script that would basically like analyze these and try to piece together files from the TCP dumps across multiple passes. So like the same file would get transmitted like 10 times, because you can imagine your packet loss from space is quite high. And so
oh my gosh,
it was the most infuriating thing to watch, because it's also this long tail. Like we couldn't tell, like we didn't have the control to tell a satellite like, oh, we only need these 5 remaining packets. It would just blast down the whole thing. So you would get like 50% on one pass, then on the next pass, 75, then 90, then 95, then 99, then 99.9. And because these bundles are encrypted, you need the whole thing. Like you can't be like, screw that last packet. Like for encryption to work, like you need the whole thing. And so we like basically wrote this, we called them DJ PCAP.
Yeah, PCAP file, read it in and like parse the data.
Just spinning those PCAPs. Yeah, spinning those PCAPs. So DJ PCAP was just trying as hard as it could to assemble from these TCP dumps. And that's how we got our first imagery. This issue has since been resolved, but the first imagery from our satellites was basically rebuilt through this crazy kind of bespoke process. And again, I think that kind of like goes towards the whole theme of the space segment moves much slower than we can move on the ground. So we're always trying to think of ways like, how can we deal with this on the ground? How can we fix this on the ground? And I think that's probably the most harrowing story out of all of them.
What a way to get started.
Yeah, that was a stressful couple of weeks.
Oh man, it was for weeks. And then I just feel like images, like it's so easy to mess up, like into like mess up imagery. You know what I mean? Like you need high resolution to really be able to like do things. So like,
well, and then the even better wrench that got thrown into this is that some of the packets would be corrupted. So we would try and reassemble, and then we would dedupe like multiple of the same piece of imagery to make sure like it was the same on multiple passes. So it was almost like you kind of needed like 2 copies of an image to make sure that it was all good. The other thing I will say, so a lot of this work we did at one of our vendor partners down in Sunnyvale, and I took back to our office. They had Baja Blast there, and it was the first time I had ever seen Mountain Dew Baja Blast in the wild. And when I tell you, like we completed that first piece of imagery, and my coworker and I were just like, Baja Blast time. And that is a core memory for me now. Is Baja Blast is success.
Love it.
That's
Awesome.
That is awesome.
Andrew, thank you so much for coming on the show. This conversation has been a rocket of a ride. And, I had to get one in. It's all right. And I learned so much.
Justin, you're killing me.
Where can people find you to ask more questions? Or I mean, I know orbitalsidekick.com is the website for the company, but I know you're available, or at least somewhat social online. Where should people reach out and find you?
Yeah, so I'm Code Brewed on Twitter. I also hang out in the Ship It Slack. I'll give you guys that Slack
great place
plug.
to go.
Yeah, great place to go. So check that out. I'd say those are probably the 2 best places to get a hold of me.
And by people, he means me, so we can be besties.
Oh, I'm also on Mastodon now. I'm on Mastodon also as Code Brewed.
Awesome.
It was nice meeting you. That was so cool.
It was great to meet you as well.
Well, friends, I have some good news for you. It is launch week once again for Sentry, and I'm here with Rahul Chabria from the product team at Sentry. So, Rahul, what can you tell me about the launch week this year for Sentry?
In March, we're making a huge investment into our product platform. We're trying to make it faster, better. In November, we shared a sneak peek about our new metrics offering. So now developers will be able to define custom metrics they care about and monitor how quickly their app is responding to the business measures they have to be accountable for, plus also like the customer experiences that they've committed to. And that's going to be available in an alpha. People can sign up to get access. We'll turn it on for them like within a couple of days once they write in, and they can get going right away. And on top of that, it's like we are looking more at how do we make the product smarter. Now, I know the world is talking about AI and ML, and they're all solving like, we think like entertaining problems, but Sentry's taking a more thoughtful approach to it. We are trying to look at what is the developer trying to do? Like our goal is not to have you sit in Sentry all day long. Our goal is not have this like be a tab that you need to keep open. Our goal is to have this be a tab you open when something is wrong, give you the information you need right away, tell you how impactful it is to your user base and if you should care. And if it is something you should care about, here's how to fix it. So we're taking a broader look at how developers use the product. Where's the noise they're seeing? Like, are they seeing repeat events? Are they seeing like things that are not critical rise to the top and have to automatically resolve them or ignore them? So we're going to make Sentry a little bit smarter with artificial intelligence to give you a more prioritized view of the issues that really matter so you can solve them quickly and move on and not be distracted by random rage clicks that are, just ghost issues. Those are the 2 major things coming out. It's like thinking about more like defining the metrics you care about, also figuring out ways to like organize your issues so developers can actually solve those problems faster. And then we're also working on a few features for our mobile developers. Like Sentry is a platform that works with any technology you want. But for mobile developers, there's always been this like, wait a second, there was an error, but hold on, let me go dig up this device and see if I can recreate it. I can't recreate it. Okay, let me go look at the stack trace and like it's definitely something there. I'll just fix it and push a release, and hopefully those now like the crash rates go up and the crash for user rates go up. But it's always like this idea of like I still need to figure out like where's that bank of used old devices for someone running iOS 13 on an iPhone 11 somewhere. So we're giving them the ability, we're previewing the ability for mobile developers to actually see what happens on an end user session. So that way there's no question about the problem or the latency issue, and building out more performance capabilities so they can see exactly how fast their app is performing. Those are the 3 big things we're planning on talking about, aside from core platform announcements, some integrations and cool partnerships we're working with. yes, the big investment in machine learning and artificial intelligence.
Okay, Sentry's launch week happens March 18th through the 22nd. Check the show notes for a link to the launch week page. They'll be showing off new features, products. You can tune into their YouTube channel or Discord daily at 9 a.m. Pacific Standard Time to hear the latest scoop. Or if you want to get swag along the way, enter your email address at the page. We'll link up to get swag all along the way. Or join the Discord, whatever works for you. Head to sentry.io. That's SENTRY.io. I'm sure they'll link it up somewhere. Or check the show notes for a link. While you're at it, use the code CHANGELOG to get $100 off the team plan. Again, use the code CHANGELOG. Go to sentry.io.
I feel like that interview could have gone for at least 2 hours because I had so many more questions, and every time I learned something new, I just wanted to dive into it even more.
I'd have to like fight myself from finding Andrew on LinkedIn and like talking his ear off because like I know he has a day job, but like I'm gonna try to like not be the obsessive like podcast friend and be like, we didn't talk about
Like,
it.
Andrew, we need to have another call. He's like, oh, is the podcast okay? Yeah, no, the podcast is fine. I got 3 more hours of questions.
Can we just have like another space episode? Like, can we have like the space continuum to continued episode? Like,
Well, and anyone listening to the show right now, if you have topics or people you'd like to hear on the show, email us. All right. Ship it at Changelog.
like Andrew in space.
Andrew, come back. I mean, I'm actually now I'm curious, like the entire chain of like the software supply chain. Are they doing signing and security? Is that even a thing? Do people like because it's isolated space? Like I don't know. Like we didn't even go into some of those details, but I know there's a lot of components in running software on literally like these metal devices flying through the air. That sounds just so fascinating in a lot of ways. Then now whenever I have a failed hard drive in a data center, like I'm not going to grumble that I might have to drive somewhere.
I was thinking that. I was like, okay, there's a lot of ways and reasons of writing software that makes me like severely nervous in production. But like I didn't even think about like how you break stuff in space. Trying to think that's hardcore. Like
Or how
and
you
the
get
fact
around it. That's so cool.
yes.
Yeah.
That part where he was saying how they had to like get down the packets and they were all broken up and stuff, and I was like, oh man, like trying to solve that in real time, you know, like how do you solve for like, hey, we're gonna send this up and you have no control over like dependencies and how people are gonna keep something long term or not, and you have to make these decisions before, you know, you have I mean, I guess you in a certain like they have like a lot of release notes, but kind of like you don't know what's going to happen in 2 years. A company could dissolve, you know, and they could stop updating said software. And then what do you do? It's just running in space. Like that is a lot.
For the outro on this show or on today's episode, we'll talk about what I've deemed as fresh open source software, fresh OS. I don't know what we want to call it, but some cool something that you might want to look at. These are libraries or command line tools or something that we just found that we thought was neat. And for this week, for mine, I was actually making some random TikToks about networking, and people replied with some tools that I had never heard of before. The first one is called Dog, which is like if you're used to looking up DNS names and you're using Dig, someone wrote Dog, which is a Rust CLI tool to look up similar tools. The command line syntax is similar, but it has cleaner outputs, or at least cleaner for a human to parse. And so that was the first one which I had heard of. And someone actually replied back that there's another one called Doggo or Doggo, which is dog written in Go, because they wanted different headers and things in the output. And so in both cases, they're Dig replacements that are a little more human friendly. And I really like that because sometimes when I'm using Dig, I'm just like, oh, I should just use it. And then I'm looking at a paragraph of output that I don't know which part I need. And in this case, Dog and Doggo were both a lot easier just to run. Same sort of syntax, look up a host name, find an IP address, MX record, something like that. But much easier for me as a person to read the output and to filter it with things like grep and sed.
Also, I think it just shows how excited people are to rewrite things in Rust. I think Rust is really efficient and awesome, but it's like, I think if you ask people to rewrite anything in Rust, they will try to do it at this point.
Yeah, there's a lot going on with rewrites of all the old tools in Rust, and some of them add functionality, some of them break, what you might be expecting. But in my opinion, a lot of them are better, and that's just cool to have tools that are easier to use.
Not just that, but I hope that when people get more excited about open source projects, they're more willing to like contribute to them and maintain them and to kind of give back. So I think it's really good because Rust has so much like adds so much value, you know, in like security and being like better performance wise. And the fact that people are getting so excited about it means they'll have more tools for it. People will contribute more and it will help it grow. So that's awesome.
Yeah. What do you have?
So I had to find a way to make first graders think that Java was cool. And I needed to say other things besides Minecraft and the fact that it, you know, Netflix.
But that is the coolest. So
yeah, then you had to explain to them how Java and Minecraft work together, and that was a whole other thing. So I was looking for different projects that Java is the basis for, but that would appeal to a younger audience, right? So like, what kid doesn't love space? I love space, right? And you always have to like be cool when you're going to your kids' class because you have to like not let them down. Like you have to be the cool parent. And I was like, how do I become the cool parent, right? So I found this really cool Java open source project that is a NASA project. And I didn't know that NASA actually had open source projects. So that made me like super excited because I love NASA. And it's a Java Astrodynamics toolkit. It's a open source software library, but it has all these cool software components for space missions like design, trajectory, optimization, analyzing of navigation and guidance and control systems. And it also does spacecraft simulation, including 2D and 3D visualization. And I thought it was so cool that this is not only like an open source project, but like we all grew up like learning about like space. And I feel like that's like a phase that's up there with dinosaurs as a kid. And the fact that you could maybe contribute to this, you know, and just see how it all works. Like, I don't know, I was always a kid who wanted to take things apart and be like, oh my God, look at all the cool parts on the inside. So just like the fact that this code lives and exists and you can be like, just see all the like classes and methods that makes like a spaceship work, it just is unreal to me.
And then you could have just like closed that loop of like, now if you can put this inside of Minecraft, then you'll have like Minecraft's in space or on the moon and you could make rockets, and that'd actually be really cool.
Hey, I had like a class of first graders who were all trying to be engineers. Okay. Like I definitely converted like 4 little girls. Okay. Like we were going to have like pink haired engineer day. Like it was going to be great.
That does sound good. Well, thanks everyone for listening to today's episode. Again, if you would like to come on the show or suggest a topic for the show or know someone that you would like to hear on this show, please email us at shipit@changelog.com. We do read the emails and we get back to you, and not everything may be a fit for what we're doing right now, but we have a great lineup of guests coming on the show and topics. So we're interested in that, but we're still just trying to find out more. And if you want to share this show with people, please do, because we are restarting it now and we want to hear from more people, and getting a larger audience to be able to learn more about what you're doing and what you're interested in. It helps us a lot just to know what to talk about and what you want to see on the show, on a future show.
More space.
That is one thing for sure. So thank you, Autumn, for joining, and thank you everyone for listening, and we'll see you next week.
Thank you for listening to this episode of Ship It. On the next episode, Justin and Autumn are joined by Vanny and Deepak from Kong to discuss managing hybrid infrastructure as code. They also kick off their first edition of TWIL. You've heard of Today I Learned. This is This Week I Learned. Thanks again to our partners at Fly.io and to our friends at Sentry. Use code CHANGELOG when you sign up to save $100 off their team plan. And thank you, of course, to our Beat Freakin' residents, Breakmaster Cylinder.